It is my great honor to introduce our work to you today. The field of multi-material 3D printing for creating conductive interactive objects is an emerging area that has developed various manufacturing methods. However, integrating high-conductivity 3D conductive structures within 3D printed objects remains a technical challenge. Currently, there are two main issues. Manual fabrication of internal circuits requires substantial hands-on time and is not stable. Completing this process automatically necessitates the use of expensive and complex, customized equipment. Our approach utilizes multi-material printing technology to construct both the whole part and its internal low-conductivity structures, improving conductivity through selective electroplating. Compared to traditional multi-material printing and surface conductive material enhancement techniques, our intercircuit method supports complex internal 3D circuit structures while maintaining high conductivity. We will now introduce the workflow of intercircuit. Users first import the basic model into the Rhino environment. Following this, users can employ our auxiliary design tools to help establish three-dimensional circuits. Our tools assist in modeling essential structures, including spatial conductive traces and their surrounding cavities, as well as support tabs and vent holes. Next, users employ consumer-grade multicolor printers, along with conductive and regular PLA, to complete the multi-material printing of the model. In the third step, users place the model in an electroplating bath to electroplate the three-dimensional circuit, enhancing its conductivity. Finally, users trim the support tabs and install components to complete the interactive object. We conducted a series of tests on the applicability of our method, verifying the cross-sectional area of the cavities used for electroplating, the appropriate angles for bending three-dimensional circuits, the number of bends a three-dimensional circuit can support, and the complexity of bends it can support in space. In conclusion, we proposed 3 applications: a multi-directional lamp, a hairdryer, and a wireless charging phone stand. Each showcases our method's capacity to create complex three-dimensional circuits, support for high-power electrical appliances, and the ability to rapidly enhance the functionality of 3D printed objects with electrical components. Thank you for your time. You can learn more details about this work by reading our late-breaking work.